So let's move on to the equations that deal with the population growth. So let's first calculate the birth rate, which we give big B or capital B. So birth rate is the number of births per unit of time, and in the same way the death rate, the capital D, is the number of deaths per unit of time. So in this case, the population growth will be equal to the number of births minus the number of deaths in a unit of time. So delta N will be equal, delta N divided by delta T will be equal to B minus D. So let's imagine that we have a population of fishes that give each month like 10,000 eggs. So what is the birth rate? So the birth rate is the number of births, 10,000, divided by unit of time. So the birth rate will be 10,000 per month. What is the death rate? As we said, not all the eggs will mature. So let's say we lose 6,000 of these eggs. So the death rate in the same unit of time per month, let's say that. So the death rate will be equal to 6,000. So what is the population growth? So this population, the change in the number of population, delta N, delta means change. So the change in the number, which is the capital N, number of population per unit of this time, which is per month, will be equal to the birth rate minus the death rate. In our example, it will be 10,000 minus 6,000. That means the population growth is 4,000 per month. Keep in mind that for simplicity, we have ignored two other factors that may affect population size. If you remember, we said density is affected by four processes. Here we have taken into consideration the birth rate, the death rate, and we have ignored the other two factors, the immigration and immigration. So that's just for simplicity. So we are considering that this is like a closed system. No individuals are allowed to move in or to move out, and this is for simplicity reasons. So let's move on. The next concept is calculating the population growth per capita, and per capita means for each individual. So in this case, big B is equal to small b multiplied by n, and in the same way, big D is equal to small d multiplied by n. So this small b and this small d is the per capita rate. So here small b is the per capita birth rate, small d is the per capita death rate, and the big ones we have already defined them in the previous slide. So this is the birth rate of the population, this is the death rate of the population. So and n is the population size. So let's say it using our previous example. Let's say in the previous example we said the birth rate was 10,000 eggs. How we calculated that? Let's say we have a population of 100 fishes. Each fish gives 100 eggs. So 100 multiplied by 100, that gives us the 10,000. So as you can see, the birth rate is equal to the per capita birth rate. So the birth rate for each female fish, for each individual, multiplied by the number of population or number of individual in the population, I mean the population size. So 100 multiplied by 100, that will give us the 10,000. The same will apply for the death rate. So let's say we have 60 deaths, so multiplied by the 100, which is population size, that will give us the 6,000. Then we have another concept which is called R. So R is the per capita rate of increase. So R will be equal to small b minus small d. So in our case, small b is 100 eggs, so this is the per capita birth rate. Then we will add the minus, then we will add the per capita death rate, which is 60. So that means that the per capita rate of increase is 40 per the unit time, which is per month. So let's put all the equations together. If you go back, you will see that we have defined that delta n divided by delta t is equal to b minus d, and I mean capital B minus capital D. Then capital B is equal to small b multiplied by n. Capital D is equal to small d multiplied by n. So what we can do, we can replace these here. So we will get this equation. I should have put this here. So we should get this equation. So what we can do, we can represent it in this way: b small b minus small d multiplied by n. And if you remember, we said that the rate per capita rate of increase r is equal to small b minus d. So that means we can replace this with this little r. So we have delta n divided by delta t is equal to small r multiplied by n. So this is the final equation that we are going to show in the next slide. So delta n divided by delta t is equal to small r multiplied by n. Usually it is written this way. So we replace each delta with the small d. So we can say dn dt will be equal to small r multiplied by n. So again, dn divided by dt is equal to small r multiplied by n. So as you can see, this is showing the change in the population size, and we have one of three possibilities. The first one, where r is bigger than 0, so the population is growing. In our previous example, the group of fishes, each individual, so the per capita rate of increase was 100 minus 60, so it was 40. So it is more than 0. So here the population is growing. Each individual is contributing by 40 new births. So overall the population is growing. The second case, when we have r is less than 0, so the population is shrinking, or the number of deaths exceeds the number of births. And the third possibility is when r is equal to 0, so the birth and death rates are equal. So overall the population size will remain constant, so 0 population growth.